Okay, so number 3 says the limit as t approaches 0 of e to the negative 3ti plus t squared over sine squared t j plus cosine t k. Now remember, I, j, and k are just those vector parts that we have there, so we're really not taking the limit of those. We're not taking the limit of the I, the j, and the k. So you can take a limit and you can bust a limit up over addition. So this is really kind of like the limit as t approaches 0 of e to the negative 3ti. Okay, so it's like you're taking this and that's times I plus the limit as t approaches 0 of t squared sine squared t j. It's going to be a number. Usually when we take the limit of something, we just get this number back, okay? Plus the limit as t approaches 0 of cosine 2t k. Now, the first rule of thumb for a limit is, all a limit is you're looking at a function and you're talking about as an x gets closer and closer to something, like if I have this, let's say, graph like this, and I ask you what the limit as x approaches 1 is of f of x. Let's say this is f of x. Okay, so that means as I'm on this graph and I'm coming along here and I'm approaching x equals 1 from the left, what does it look like it's going to? And then as I'm approaching x equals 1, if I was a bug on this graph and then I'm coming down here to get closer and closer to x equals 1, what does it look like it's going to be? Well, it looks like f of x is going to be 1. Now, sometimes that's not what it is. Sometimes f of x and the limit of f of x aren't the same thing, because like this could be a hole right here, and you could have this down here and f of 1 equal negative 1, but the limit of f of x as x approaches 1 would still equal 1. Okay, that's a little short version of what a limit is, and you talked about that in the very beginning of Calculus 1. But the easiest thing to first try to do with a limit is just direct substitution and see if you can get that. So if I look right here and I take the limit if I take the limit as t approaches 0 of e to the negative 3t, all I'm really doing is saying e to the negative 3 times 0, and I have my I out there because that's just my vector component. Well, that's e to the 0, and anything to the 0 is 1, so I get 1i, okay? Now, the second part, this one causes a little bit of a problem, because if I substitute in 0, I get 0 squared over sine of 0 squared. Well, that gives me the indeterminate form. That means I have to do something else about it. If you get a 0 over a 0, it's called an indeterminate form. It's not just undefined. There's something else that could go on. So we're going to come back to that. So we've got a big question mark there. Plus, all right, if I plug in 0 here, this is going to give me the cosine of 2 times 0. All of that, of course, times k. Well, that's the cosine of 0, and the cosine of 0 is 1, so plus 1k. Okay, so I know that I have some 1i plus, we don't know that part, plus 1k, right? Well, I'm actually going to take that, and I'm going to move that down here. Now, you'll notice when I started, I had this little chunk right here, okay? This little part right here is, now like I said, this was the basic gist of what a limit was down here below this. But of course, there's always special properties. There's always going to be special properties involved. And one special limit that we know is the limit as x approaches 0 of sine x over x equals 1. And we prove this by using what we call the squeeze theorem or the sandwich theorem, okay? But anyway, and usually you have to prove it in Calculus 1, but what happens is people just wind up memorizing it, okay? And so we're going to use it for this middle part right here. Because if I can rewrite this where it looks like that, then I know I can get 1 out of there, okay? So I know this is really the limit as t approaches 0 of t over sine t times t over sine t, right? Okay, well, because t times t is t squared and sine t times sine t is sine squared t. Okay, so that looks close, but it's kind of upside down. And the way we could see that is if I had the limit as t approaches 0 of 1 over sine t over t, okay? Because all I did was flip it over, and I know when I divide by 1 divided by sine t over t is really 1 times t over sine t, because I keep change flip. Okay, times 1 over sine t all over t. Okay, well, you can bust that up into the limit as t approaches 0 of 1 all over the limit as, and you know what, I'm going to move this so it can keep going. Let me, there we go. Over the limit as t approaches 0 of sine t over t. And then, of course, this is the limit as t approaches 0 of 1 all over the limit as t approaches 0 of sine t over t. Okay, so now, well, the limit as t approaches 0 of 1, well, if it's always 1, that's just 1. And then I know this is really what I had written, both of these, or what I had written up here at the top, sine x over x. The limit as x approaches 0 of sine x over x really equals 1. So these little yellow bottom parts are really just 1 times 1 over 1. And of course, all that's times j, right? Your little vector going on there. I didn't write it. My good math professor, Dr. Goddard, would have counted it wrong because I failed to write the j. And so all that times j. So that does give me 1j. So I get I plus j plus k. And we actually worked this problem, and I wrote it out on a piece of paper, I think, so you could get it turned in. And I made a little video just walking you through it before, but like I said, it was just a little video on there. And I think I had messed up the K part on there. I'd put 0, and then I went back and scratched on it and told you what it should be. So that should be I plus j plus k.